Assalamu alaikum, welcome back friends. In this video we are going to discuss about the glucose open and ring structure. Okay, let's begin. Glucose open ring structure. As you know, the glucose C6H12O6, the molecular form of glucose. Let's draw the structure of open structure of the glucose. C6, okay. 1, 2, 3, 4, 5, and 6. On carbon number 1 we have functional group C double bond O and H on other side. Okay, aldehyde group we have aldehyde functional group over there at the carbon number 1. Then on the third carbon write OH on the left side. At other carbons what you have to do, we have to write the OH on the right side. It's OH, it is OH, it is OH, clear, it is OH over here. As carbon has got its tetravalent, it has 4 valencies. It has got the tendency to form 4 bonds. Look at the carbon number 1, all its vacancies are filled. 1, 2, 3, 4. Carbon number 2, 1, 2, 3. Fourth one is vacant. Here, fourth one vacant, fourth one, 2 vacancies. So all the remaining vacancies over there, we will fill it with hydrogen atoms. So this is the open structure of glucose, and we call it as a D-glucose. Why D? Because I have mentioned in the previous video, the D means dextro, because this glucose molecule, it rotates plane polarized light towards right side. Why D glucose? Because it rotates plane polarized. I mentioned in the why this D glucose, because I already mentioned it in the previous video that D means dextro. This glucose molecule rotates plane polarized light towards right side. Okay, so why we are writing this D glucose over here? Because I mentioned in the previous video that D means dextro. That means that this glucose molecule, it will rotate plane polarized light towards right side. Okay, D means dextro, right, dextro. Okay, we got the OH group on the this lowermost chiral carbon on the left and the right side. That's why it is D glucose, and this I have discussed it in the previous videos. We can watch them to clearly comprehend the concept over here. Now we are supposed to go. What we are going to do over here, we have to make the ring structure of this glucose. Okay, see the carbon number 1, it has carbon double bond O. The O oxygen has got it is more electronegative than carbon, so it will try to attract these electrons towards itself and will develop slight negative charge, delta negative, and here at carbon it will develop slight positive charge, that's delta positive over there. And you see the bond between O and H. O is more electronegative, so it will develop like this, slight negative charge on O and slight positive charge on H. So this O slight negative, delta O delta negative over here, it will interact with the delta positive H, and this delta negative oxygen will interact with delta positive carbon. So the structure formed over here will be like this. Let us show the interactions. Let me show the interaction with some other color. It will be like this. Okay, okay, This will be the interaction over there. What will the structure formed? We'll get C2, 3, 4, 5 and 6. At C first, C1, we have now O, this O negative, it will interact with and form a bond with this H, because it has a delta positive, it has delta negative, a bond will be found over there, this OH bond. On the left side, it has its own H. Clear? Okay. Now this carbon being the delta positive and oxygen being the delta negative, they will form a bond over there. It will be like this. It will show this bond like this. 1, 2, 3, 4, 5 is forming the bond with the fifth carbon. It's like this. Okay. Then see, other these arrangement of the atoms are similar as you saw in this case. Let's make it. We have got OH on right side. At carbon 3 we have got OH on left side. Other carbons have got OH on the right side. That's why it is dextra. This is it will be H over here, H is over here, H and H. So this is the structure formed over there. This oxygen forms a bond with this hydrogen and becomes OH, and this carbon, it will form a bond with this oxygen and then carbon over here. So the carbon oxygen carbon bond will be formed like this. Okay. Then we'll try to make it as a ring. It will try to close these molecules. Will try to come close in a ring structure. We'll show it over here. This structure will be like this now. You see, this forms a sort of ring over there. And how many atoms are there? We got 1, 2, 3, 4, 5, 6 atoms there. 1 oxygen and 5 carbon. So we'll make a hexagonal ring because it has got 6 atoms. So we'll draw a hexagonal ring like this. 1. So this is a hexagonal ring which we are drawing, and we got this oxygen over here. This is oxygen. It has got this carbon 1. Let's draw it as carbon 1. We have got carbon 2. We got carbon 3, carbon 4, carbon 5. And this carbon 6, this one is out of the ring. This is not inside the ring, but it is out of the ring. It is attached to carbon 5. We'll show it like this. It is CH2OH. It's H over here, not OH, sorry. CH2OH. Always write this CH2OH on the top. This is CH2, okay, CH2OH. Got it? This carbon 5, and then this CH. This H will be on lower side. So always the CH2OH will be on the top. Clear? Then what will be the arrangement of the other molecules over there? Those on the right side and those on the left side. What will happen to them? I will tell you. Those who are on the right side, remember this, right side down, left side up. Right side down and left side up. Okay, I'll show it here. Left side up. Now see, those who are on the right side, this is the right side, this being the right side, this is the left side. Right side down. So at carbon number 1, what we have OH. So OH, right side down, so OH will be here. Clear? And at C2 we have OH. At C2 we have OH again down. At C3 we have H on the right side, so it will be down H here. At carbon 4 we have OH again, and carbon 5th it's already filled, because I told you the rule is that we have to write the CH2OH on the top. The remaining is the left side on top. Okay, upside. This is carbon 1, it has H on left side. Carbon 2 has H on left side. Okay. Carbon 3 has OH on left side. Carbon 4 has H on left side. So this is the ring structure of glucose. Got it? So this is the ring structure of glucose. So we have got a hexagonal ring over here. We got a hexagonal ring over here. This is a hexagonal ring. Hexagonal ring. This ring, hexagonal ring, we call it as pyranose. Hexagonal ring is called pyranose. And how many carbon atoms are there in the ring? We have got carbon 1, 2, 3, 4, 5. We got carbons. We got 5 carbons. 5 carbon atoms in the ring. And how many oxygen atoms? We get just 1 oxygen there. 1 oxygen. 1 oxygen atom in the ring. So in case of hexagonal ring or the pyranose ring, we have 5 carbon atoms and 1 oxygen in the ring. Whereas the 6th carbon, that is C6 over here, it is outside the ring attached to the carbon number 5. Clear? Okay. Second thing about this is the name of the ring. We call it as, now this is called as, this ring structure is now known as D-glucopyranose. D-glucose. Pyranose because it has a hexagonal ring. Glucose is the structure. D I already discussed with you, dextro. Clear? But here it is called as alpha D-glucopyranose. Okay. Next video we will discuss about the anomos, and I will try to make you understand why alpha and beta is over there. What's the difference between these two? Why it's alpha over here and other structure we will have beta. I will discuss it in the next video.